Hi everyone, welcome back. And today we will be discussing another problem from greedy approach section from your SD sheet. Let me just quickly check if we are live, and I'll start with the question. So the question for today is very simple. I don't know, after solving yesterday's problem, this shouldn't have been in the list. This is that simple. But okay, let's discuss it. We are live. So this is the problem, maximize toys. Okay, let's have a look. Given an array of length n, this is an array that is given to you, a k value has been given. You have to tell that what is the maximum number of toys you can buy with k amount. So understand it in this way, that you have k rupees with you, right? And these are the prices of different toys. This one costs you rupee 1, this one 12, 5. So maximum how many toys can you buy with this much amount with you? Okay, I'll just write this test case and then we will have a look. So what do we have is 1, 12, 5, 111, 200, 1000 and 10. Okay, so if I have 50 rupees, I have to tell with this amount maximum number of toys that I can buy. So if I start from the first toy, let's see, the value is 1. If I choose to buy this toy, I'll be left with 49 rupees. So okay, I have bought this toy. Now with this 12 rupees, with this toy of 12 rupees, I'll again I can buy this. Okay, and now what is the total value? Basically I'll keep track of total amount that I have spent. This is spent amount. Okay, and total amount that I have, we'll see when it exceeds 50. I have bought this one. Let's buy this one. The amount that I'll get now will be 18. Okay, the amount spent is 18 now. If I buy this one, the amount will exceed this rupees 50. So definitely I should not buy this one. Let's go to the other one. If I add this one, right, so amount will exceed rupees 50 to 18 it will become. I cannot buy this toy as well. So I'll move forward. Again, not possible to buy because total amount is 50. If I buy this one, what is the amount that I'll have? It will be 28. Okay. Now I have spent 28. I am still left with some toys, some amount with me. But is it possible for me to buy any more toys? No, definitely not. So are you going to check like this for every toy that you have if the amount is exceeding or not? Is that what you are going to do? Let's take one more example so you will understand better. Obviously for this the answer is that 4 number of toys is what we can buy with this amount. Let's take one more example. For example, I have this 20, 30, 50. Okay, the amount that you have with you is 100. Now with this 100, definitely you can buy all the toys. It's not a very good example. So what you have done here, you are just simply checking every toy, doing the total sum and see if you are exceeding this value. If not, you keep on adding the toys. Now the point here is that you're getting answer from this approach and this also and this also. Where will this approach be an issue? This is just a simple brute force approach, that is going at every toy, adding it to my sum. Okay, checking if that sum exceeds your k value or not. If not, you keep on adding it. If it does not, you keep adding. If it exceeds, you just move to the other toy. This is one thing. The other thing that you can do is simply what you can check. The point here is we have to maximize the number of toys, right? If I want to maximize this number of toys, for example, I just say, let's do one thing. Let me do one thing. What? That suppose this is, just give me a second, I'm just creating a test case so that you can understand why we are going towards an other optimal approach. So I'll just 18 and this will become 218. So let's say 250 is a total amount. Fine. Okay, or what can I do? I'll just create a test case like this: 10, 5, 20, 35, 30 and this 15. For example, k with me is, let's say I will buy 10, 5, 15, or I will add one more. Let's say one more. I have 5. Fine. Wait, I'm just finding a good test case. For example, 5 5. Okay. This is fine. So sorry guys. So for example, total amount that you can spend is 10. So what is the maximum number of toys that you can purchase? Got it? Okay. So the thing here is, if I just simply iterate over this given array, I'll see my first toy costs me 20. So the sum becomes equal to, 10. So my sum becomes already equal to 10. Now if I go to the other one, if I include it, my sum will become 15 and that exceeds k. So definitely I'm not going to include it. I'll check for this one, I can't include. This one can't include. This one, I'm already at my maximum, can't include. So basically you ended up buying only one toy. But do you think this is the maximum number of toys you can buy with rupees 10? No. Why? Because you can buy two toys, one of rupees 5, other one of rupees 5. Getting my point? So here you are buying two toys if you choose to buy one toy of rupees 5 and the other toy of rupees 5. So in order to optimize this, now very simple, I am sure you must have already guessed that we are going to sort this array, right? So this case was not very observable in this test case, that's why I created it. So what can we do? We know when I'm iterating over my array, the smaller the value of that toy is, the more I can add that toy in order to maximize the number of toys within that amount, right? If I have more toys with smaller amounts, with less price, I can add more toys rather than buying one toy of a bigger value. So that is the only intent. So if I choose to sort this array, coming on the first test case, what is it that I'm going to get? I'm going to get 1 5 10 12 111 200 and 1000. This is what I'm going to get, right? And now just simply iterate over your array, keep adding, same thing, keep adding. If the moment your price exceeds rupees 50, here your price, total price, if you go further and try to include this, your price will include 50. You can only spend rupees 50. So you simply come out of the loop, and you know now going forward will not help you, because all the toys will be of higher price only. The moment you will find that the price adding a toy will exceed my given amount, I'll stop right there, and the number of toys that I have added so far will be my answer. Got it? So that is the whole question. I'm just moving to the code now. If you guys have any doubts, you can ask me. Cool? Simple code, nothing much to explain here. So we are taking time for sorting, that is n log n of time complexity. We are sorting it and then we are iterating over it once. So at max it's n log n, plus for iteration it's taking n. So predominantly we go of n log n is the time complexity that we are going to take. Okay, so let me just write it. Let's take int count equal to 0, and I'll sort arrays dot sort arr. First I have sorted it. Now I'll take int answer equal to 0 for int. Right, you are checking, you're just adding the count, which is actually the price of your toy, arr of I. If this count is less than or equal to this given value k, then you will add 1 to your answer. Why? That is the count of toy that you have chosen. 1 toy, 2 toy, 3 toy, like that. Otherwise, the moment you will see that count exceeds k, you just break, come out of the loop and return your answer. Fine, then that's all about this problem, everyone. Let me know if you have any doubts. I'm sure you wouldn't have any. So let's wrap it up then and see you all in the next lecture. Bye bye and take care.